Well, here we are. We made it to the end of the semester, a little worse for wear. And we're going over the final exam study guide. It has around 40 questions. I forget exactly how many. It's pretty thick. There's a table of formulas at the back, which we might need. 39 questions. The first four are showing up on the board here. Let's talk about them for a minute. So problem one has to do with this histogram. It's the histogram of number of absences for students in a class. So the way we look at this is here on the horizontal axis is number of absences, say like 3 absences. And on the vertical axis says how many students had that many absences, 6. So there were 10 with none, 9 with 1, 6 with 2, and over here 7 had 2 absences, and these out here with lots of absences, just 1 student each. Describe the shape. Well, to find the shape, we find the center. The center divides the area in half, so you just do that by eye, or you could do it by counting. Area is the same as number of observations in a histogram. So if we cut the area in half, we're cutting the number of observations in half. They're sort of listed in increasing order. That's the nature of things here. So when we cut the area in half, finding the position that would be at the center value if we counted from the bottom to the top or top to the bottom, doesn't matter. So we find that place here. The center is around 2. So the center is located on the horizontal axis. So you divide the area in half and read off the number on the horizontal axis. That's the center, otherwise known as the median. And then to find the spreads, we measure out from that center as far as you have to go to get the highest value and smallest value from 0 to 19. We might call that the spread, 0 to 19. And then we look to see which distance is further from the center to the extremes. The longer distance is the direction that we say the distribution is skewed in. So if from the center to the right extends further than from the center to the left, we say skewed right. If to get to the furthest values we have to go further in the left direction, we'd say skewed left. So this one is skewed to the right. And then we know for distributions that are skewed right, the mean tends to be greater than the median. And the reasoning behind that is the mean is like a balance point. Here, if we tried to balance it there, we have the same area on each side, but this side is closer to this median than the other side, so the other side would cause the distribution, if you tried to balance it like a teeter-totter, to tip down. So we'd have to move the mean over to find the balance point. So that makes the mean larger than the median. And then we want to count how many values are 7 or more. We can easily do that. 2, 3, 4, 5, 6 values 7 or more. Did that. Number 2 says, take the data and make a stem and leaf plot with split stems. There's 2 ways we can split the stems. Here's one way, 0 through 4, 5 through 9. Here's the other way, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 5 piles for each stem number. Here's 2 piles for each stem number, which I used. So over here, it's the 60s. 60 through 64 appears here, and 65 through 69 appears there. And we just read them off. So that's 63, 61, 68, 66, etc. 71, 73, 77, 83, 90. So those are all the values there. There's 30 of them. And ordinarily we'll take that stem plot and we'll put the leaves in order. Put it here. Leaves in order. The reason for doing that is it lets us find out where the median and the quartiles is. Before we go there, I guess I was supposed to say, what's the shape here? I would say roughly symmetric. If this 90 was missing, it'd be clearly roughly symmetric, but with a 90, maybe possibly slightly skewed to the right, but I'd still say roughly symmetric. So here we have the leaves in order. We have 30 values. The median is at position n plus 1 over 2, which is 30 plus 1 over 2, which is 15.5. So I count up between the 15th and 16th position. Once they're in order, I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Draw a line between 15 and 16. That line divides the data into 2 piles of size 15, 15 above and 15 below for the 30 total values. And we'll find the median by averaging the 2 values above and below that position. So 72 and 73. So 72 plus 73 over 2, 72.5. And then we see how many values are above and below. It'll be a whole number. If we happen to have selected a number when we pick the median, we don't use that number in our calculations, and we have the same number of values above and below that actual number. Here we didn't pick a number, so we have equal number of values above and below that line that we drew there that's not really marking a spot in the data set. So it's 15 values above, 15 below, so we do n plus 1 over 2 for the quartiles as well. 16 over 2 is 8, so then we count up 8. 1, 2, 3, 4, 5, 6, 7, 8. And we could also count down from the median, 1, 2, 3, 4, 5, 6, 7, 8. Or down from the top, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. All those countings by 8, either from the center or the top or the bottom, will give you where the quartiles are. So they're at 68 here for the lower quartile and 77 for the upper one. It's important to mark it so you know which 77 we chose, so I could tell if that's what you were doing, that you counted the right amount. Here's number 3. It says make a normal density curve with mu is 200 and sigma is 40. The story is we draw a bell curve here indicated in black. We read off the bell curve what the standard deviation is. It's the distance from the center to the steepest point in the curve, that horizontal distance. Then we mark off on the x-axis blocks that size, like that. And then we use that distance as standard deviation. We mark the mean where it is in the center, and then we go over by that distance 40 for each standard deviation mark. So we marked it off here, so 40 plus 200, 240, then 280, then 320 and 40s. And going down 40s, minus 40, minus 40, minus 40. So all these are 40 apart. 80 to 120 is 40, 120 to 160, 160 to, they're all 200. They're all 40 apart. And then so we marked it off, we labeled the x-axis, we're done. We're going to need this in a minute. We're up here somewhere, okay. So now we're at number 4. It says, suppose ACT scores are normal with a mean of 20.9 and sigma is 4.8. What percentile is 18? So to find percentiles, I compute a z-score. Here it is. X minus mu over sigma. X is 18. Mu is 20.9. Sigma is 4.8. I get minus 0.6. I go to the tables and get 0.2743. That says area left. 0.6 is 2743. The percentile is just the percent less than that value. So we get 27.43%, or the 27th percentile, or the 27.43th percentile. And then the second question is, how do we find the top 10% of students? Well, if I go to the tables, I would look for a 90% in the table, so there would be 10% above, because I want to be the top 10%. So I go in there to the 90th percentile, trying to find it in the tables. 90 shows up here. 89, 89, 8997. 8997. 1.28. See where I am. I'm in this third white stripe here. 1.28. I happen to know the value is actually 1.282, but 1.28 would work fine. There will be find values from a z value. As we go, x value is mu plus z sigma. So the mu is 20.9. The z for 90% is 1.282. And sigma is 4.8. Out comes 27053. So we say he's 27 or higher. This is the approximate place where the top 10% of students have scores. All right, made it that far. I tried doing this just a minute ago and my camera turned off on me, but so far it hasn't. So good luck. We made it through the 4 questions.